Cool. So I'm going to start this little workshop on blockchain. This is a bit of a mixed presentation put together with some slides that I used at a workshop that I did in Barcelona recently. And hopefully it's going to work for... I've given this presentation to very mixed crowds in the past, so there'll be people there that are, you know, from Bitcoin meetup scenes or involved in Ethereum or whatever, and then complete newbies as well. And I hope that the presentation will give a kind of original angle on things that will be interesting for everybody. I'm going to present myself again for those who don't know me. My name is Klara Breeke, and the main focus in my work at the moment is researching blockchain governance. So I'm comparing different consensus algorithms across different blockchain applications and doing a kind of, let's say, more political analysis of the kind of architectures of these different protocols. My background is very mixed. I come theoretically from a background of political economy and human geography. And I've worked as a designer on kind of large technology projects, and also have a kind of background in art and various other filmmaking and stuff like that. But yeah, so kind of a bit of a mixed background. So just to kind of get an idea of like the mix of crowd we've got here, I think most of you have heard the word blockchain before. Who owns any Bitcoin? Cool. And you use them for transactions, or you use them to both? Who here has heard of blockchain for the first time coming to the Media Lab? Okay, everyone's kind of heard of blockchain before. So I probably don't have to do the kind of first spiel of like, you know, the fact that it's moved from being something that was relatively, you know, a small thing to something that now, you know, major financial institutions and governments and banks and technology companies across the world are really looking at quite seriously, and there's a lot of heavy interest on blockchain technology right now. So it's moved from something that was a kind of core aspect of the kind of Bitcoin protocol to something that is now being kind of bounced around as a hype and as a kind of promise to solve a lot of different problems. So we're going to kind of disentangle that a little bit. But yeah, so this is something I usually this is part of the kind of members of the Hyperledger project. So you get an idea of like the mix of basically tech and large financial institutions that are partnering with these kinds of projects. Anyway, so normally when I explain the blockchain, I start with basically just explaining Bitcoin and what it does. This is a kind of brief sketch of, you know, banking structure. Right now we've got a central bank that determines things like money supply, interest rates, monetary policy in general. Money supply is a bit kind of yes, maybe, maybe not. You know, with the kind of, let's say, debt-fueled economy, we're seeing a lot of private money creation happen as well. That's a kind of separate issue. But so, in a kind of very schematic way, what banks do is they are what mediate our transactions. So when I want to send €5 from my account to someone else's account, the bank is the authority that has the list of transactions and the balances of the accounts and says, I now have 5 less euros in my account, and the other person has 5 more euros in their account. So the bank holds that list. The bank is the authority that says this is in fact what's happened, this is the truth. And if I try and send those same 5 euros from my account to someone else's account, I can't do that because the bank says, no, you don't have those 5 euros anymore, yeah? And this is also what's like different about digital money, right? It's numbers that are changing on a list rather than a physical thing that you hand around. So what the blockchain does is, well, what the blockchain is fundamentally a list of transactions that everybody hold in the network. So instead of having a central authority that holds that list of transactions and that enforces the fact that I have £5 less in my account, someone else has 5 more, this is done in a decentralized manner. that is the kind of proposition, let's say. That's the kind of at the core of what the blockchain does. It decentralizes a process that you otherwise require a central authority to validate. In the cryptocurrency scene, this is kind of a process that's called disintermediation, and there's a lot of fascination with this idea of being able to disintermediate, so getting rid of middlemen or middle authorities that that mediate our relations to other people. I put a question mark after that because there is the question of whether getting rid of an institutional body is a form of disintermediation or whether it's a form of kind of re-intermediation into a different type of mediation, a different type of technology, let's say, yeah? So let's look a little bit at the type of mediation that's going on. So the blockchain, which I have just explained, basically decentralizes this ledger. And it does this through a process called mining. So what happens is, in order to guarantee that, let's see where to start. So fundamentally, what you have is a string of transactions that are each hashed together. And what you want to find, what you want to do is you want to make sure that the same transactions can't be considered valid. No, sorry, let's say, I'll start again. I'm a little bit tired today, so I'm just going to apologize. How do you guarantee, when you no longer have one authority, which transactions to consider valid? So if I want to send €5 from my account to your account, and I try and send those same €5 to your account, how do we come to an agreement in a decentralized situation about which transaction to consider valid, the one I send to him or the one I send to him? This is done through a computational process that's called proof of work, and that is essentially what mining does. Normally people think of mining as a way of creating new Bitcoin, but actually it's a kind of core security aspect of the network. The way that this takes place is the miners take a group of transactions. Is everyone kind of more or less on board so far? Is everyone more or less on board so far? So miners take a group of transactions and they put them into what's called a block. And they do this by hashing the data. Hashing basically means you have some information, you run it through a computational process, and you have a string of numbers that come out the other end. That string of numbers is unique. If you change anything in the data, that string of numbers is going to look completely different. So what this means is people can't go back and tamper with the transactions. If they tamper with the transactions, it's going to become immediately visible and it will no longer be considered valid. So this is a kind of, one central aspect of the security. So the miners, they take the transactions, they hash them, they have a string at the other end, and then that block is considered valid and is added onto the blockchain. Now, there's another aspect to what's called proof of work, which is, well, there's another aspect to the blockchain which is called the proof of work, and that is that not all blocks are automatically considered valid once they've been hashed. Instead, they've made it difficult. They've made it difficult to mine these blocks. Why? In order to kind of space out the money supply so that new Bitcoins aren't created all the time, and in order to make sure that there's a kind of, let's say, regular expectation, a regular idea of how quickly the network is going to grow in terms of money supply. So this is where it kind of emulates the, gold, let's say. People compare Bitcoin to kind of digital gold. So they've made mining difficult by setting what's called a difficulty target, which means the block needs to comply with a set of rules, and that set of rules looks a little bit something like this. These are my kind of little funky graphics. In the hashing process, the miner needs to find what's called a nonce, which when it's hashed with the transaction data, produces a number that is considered valid, and that number needs to meet what's called the difficulty target, which is it needs to have a certain amount of zeros in front of it. This sounds very strange and can be very new for a lot of people to understand because it's random. It's like, what does this mean? Why? You know, there is no why. It's just a very clever way to make it difficult to create blocks. The difficulty target is kind of shifts every 2 weeks depending on the kind of computational power. So depending on how good the miners get at mining new blocks, in order to average it out so that every 10 minutes a new block gets created. Once a new block is created, the miner gets a reward. So this is what a lot of people know about with Bitcoin is there's this strange mining process, some mathematical something rather, and then you get Bitcoin, you get rich, right? The reward is there to incentivize the security of the network. It's there to incentivize the fact that there are, you know, people that are willing to spend their computational power in order to serve this function of validating transactions and securing the network. Is that more or less, people understand more or less what that is now? So yeah, mining, you create blocks on the blockchain, and what the blockchain does, the reason why it's chained together in this kind of manner, first of all, you can see the entire history of all transactions. So the interesting thing about Bitcoin is it kind of flips what we're used to when it comes to bank accounts, meaning you can see every single transaction, but the transactions are not connected to any specific identity unless you reveal that identity. So you can have a lot of different Bitcoin wallets and so on and so forth, transact with different kind of wallets, and you don't need to reveal your name, but the transaction data is fully visible and you can search it all the way back to the very first transaction in Bitcoin. So how does the network come to consensus around which transactions to consider valid? First, there is the mining process that I just explained. But you have a lot of computers, a lot of miners in the network who are mining blocks at the same time. So sometimes you'll have forks in the chain. There'll be a fork in the blockchain. You know, a miner validates some transactions that aren't considered, or that clash with other transactions mined by other miners. So what happens in the blockchain is that it's a process of emergent consensus, meaning normally for large transactions, there is a recommendation that you wait for a few blocks before you consider that transaction fully valid. So what I've tried to kind of sketch out here is that there is a rule that says that the longest chain is always the one that's considered valid within the blockchain. So going that way over, the lighter gray is less kind of confirmed, and then the blocks at the back are the ones that are fully confirmed, and you've got chains on the side, and the longest chain is the one that's considered valid at that point. Is that all more or less clear? Cool. So that's kind of more or less a brief sketch of the blockchain as it exists in Bitcoin. Uses proof of work as a consensus algorithm, meaning you have the mining process to validate transactions. And essentially, just to recap all the way back, the blockchain is what makes it possible to come to an agreement about what data to consider valid in a decentralized network without needing a central authority in order to validate that. So one word that gets bounced a lot within the kind of Bitcoin circles is trustlessness. And what that means essentially is you no longer need to trust in a central authority, but you also no longer need to trust anyone else that's in the network in order to use the system. And that basically comes down to the way the mining process is set up. Meaning that the cryptographic hashing makes it almost impossible to falsify or to tweak any of the data once it's added onto the blockchain. And the decentralized validation and storage of the blockchain means that it's extremely hard to hack. You would need to control, over 51% of the network in order to actually modify or tweak any of that data. So as the network grows, it becomes more and more secure. You've got thousands of computers spread all over the globe that are crunching these numbers that are adding onto the blockchain, meaning you need to control a lot of computers in order to actually like tamper with the transactions. So this is a kind of, let's say, one of the major aspects of what people are kind of fascinated by with Bitcoin, and also one of the reasons why it's still remains one of the main cryptocurrency, or the main cryptocurrency, because it is that large and you've got that many miners, you've got that many what's called hashing power, that much hashing power in the network. So the reason why the blockchain is super hyped right now, and there has been a kind of, let's say, a social, political, economic process of kind of trying to separate out the blockchain from Bitcoin. And you've got, you know, most of the kind of, let's say, Bitcoin scene is not very happy with this process at all and sees it kind of as a bit of a political attack, let's say, as a way for banks and central banks to kind of recapture what is quite a major financial and technological innovation, and to try and control that. So what we see now is a lot of hype and a lot of discussion around blockchain, 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 and trying to kind of push Bitcoin a little bit to the side and make it kind of seem like the kind of old and clunky version of something that is, yeah, shiny and new. But what's interesting, why we talk about blockchain, why it's sometimes interesting to talk about blockchain separately from Bitcoin is because it highlights the fact that you can use this system to validate any type of data in a decentralized manner. You can do this using the Bitcoin blockchain as well, and Democracy Earth are doing exactly that. There is like work being done in Bitcoin on side chains. You can kind of hash other stuff onto the kind of Bitcoin blockchain using transactions in order to do that, and that's what they're doing with voting. But I thought we would go through maybe just a little bit of kind of other looks at how the blockchain is kind of evolving a little bit, and what other types of consensus protocols exist out there that are not based on mining or proof of work. Yeah, this is like some of the areas where people are looking at blockchain: identity, land registry, domain names, contracts. So consensus protocols, these are the 3 consensus protocols that I'm looking into at the moment. So proof of work is what we've just been looking at, and there's proof of stake and proof of cooperation. So some of the critiques of the Bitcoin mining process is that, first of all, you've got a ton of computers and like factories of computers, that are crunching numbers and are mining blocks, spending a lot of natural resources in order to kind of solve a hypothetical mathematical problem that doesn't necessarily, have much benefit. So there's environmental critiques of that. There's also critiques of that has to do with centralizing tendencies, which basically means that, in the beginning of Bitcoin, loads of people could mine and create, new blocks and new Bitcoins. Loads of people were involved as full nodes validate transactions, and it was, a decentralized network. As the network grew, and as computational power grew, people focused more and more computational power on solving these mathematical problems. New hardware was developed specifically for that, and it became less and less accessible. So, any single individual here in this room, you would probably not be able to, successfully mine any blocks on Bitcoin, because we just can't compete with the computational power of other miners at the moment. So there is a kind of centralizing tendency in the network that's been critiqued a lot for. And I'm going to go into that a little bit, because at the end of the presentation I want to talk about 2 examples of kind of major events that are happening in the cryptocurrency scene this past year. One of them is a Bitcoin scaling conflict, and the other one is what's called the DAO hack, or DAO exploit within Ethereum, which is a different blockchain application. And they kind of show, there are like major tests to some of the core assumptions and core claims of what blockchain is and what blockchain can do. So I'll talk about that a little bit at the end. Proof of stake is another model for validating transactions. So it's a different consensus protocol for blockchain applications. Ethereum is looking at implementing this, but I think they're still using proof of work. I'm not quite sure. I think they're still using proof of work. Essentially, proof of stake means that you have, instead of a mining process, you kind of put a bond on a specific transaction or a specific block of transactions. So what that means is whichever block of transactions that has the largest, let's say, kind of bond, as in a cryptocurrency that you attach to that block of transactions, that's the one that's considered most valid. So what that means is that essentially those with the biggest stake in the network are the ones that determine which transactions get validated or not. And there's two ways of looking at that. You can look at that as in like, well, that means that the rich people have most power. Yes, that is true. But you can also look at it as in those that have most at stake in the network are the ones that have most power, meaning it's not in their interest to undermine the trust in the currency or undermine the trust in the network. So, because they have a very large stake, they're not going to start validating transactions. They're only in their interest because people will simply stop using that currency, right? So there is a kind of, it's a different model, it's a different kind of mentality, different kind of set of incentives around that. That's proof of stake. Very briefly told. There's lots of different versions of proof of stake. I mean, each of these consensus protocols have very different kind of versions to them. Proof of cooperation is something that's used and invented by a cryptocurrency called Faircoin that's based out of Barcelona, but they operate in a few other countries across the world. And it's a cryptocurrency that is intended for the kind of cooperative movement. And the interesting thing with Faircoin is that it's basically the opposite of Bitcoin. And it's the opposite because it's absolutely not trustless. It's heavily based on trust. It's heavily based on assembly-based decision-making processes. And instead of having a network of miners, where it doesn't really matter who's taking part. If you think about Bitcoin, it's a system that's designed for, it absolutely does not matter who else is part of that network. The security of the system and the way the incentives work means that even a kind of malicious, it's very difficult to attack the network. And they use, it's heavily based on game theory. They use financial incentives as a kind of security function, and it is really designed for a kind of trustless situation, a place where, a kind of condition where you don't know who else is going to be using the currency. Faircoin is very different. It's exactly the opposite, and the way that they do validation of transactions is they have what's called certified validator nodes, and these are basically like, small collectives that have a computer and that then take turns creating blocks on the blockchain. So it's, exactly the opposite. You don't get any reward. There's no financial incentive to take part whatsoever. And in fact, that's kind of part of their security model. Because if you can't get rich fast, you're not really going to try and get involved or attack the network or, it's like, it just doesn't work that way. Obviously, there's like questions that are going to come up later down the line as that network grows. There will be more incentive to try and kind of game it and try and attack the network. But at the moment, it functions very much as through reputation, informal reputation, and through a kind of set of ethical and political criteria around decision-making processes. So in the Faircoin architecture, you have what's called local nodes, which are collectives that have open assemblies, consensus-based decision-making processes, and they are basically exchange offices between local currencies, euro or whatever, and Faircoin. and they facilitate and help any local producers in that area, cooperatives that want to kind of engage in this kind of global network of currency and trade. They help facilitate that. So you've got local nodes, and you've got certified validator nodes that do the validation of the transactions. So it's interesting to analyze this in relation to Bitcoin, two completely different scenarios, two completely different models, two completely different ways of dealing with trust. Yeah, that's proof of cooperation. That is what I was just mentioning. Right, yeah, so that's a bit of an overview of consensus protocols and a couple different blockchain-based applications. I would like to talk a little bit about, let's see, I could talk a bit about Ethereum, or I could talk a bit about the Bitcoin scaling conflict, or we could do both. Yeah? Both. Okay, well, let's start with the Bitcoin scaling conflict. So, in Bitcoin, in the protocol at the moment, it's specified that blocks on the blockchain, that they have a hard limit of 2 megabyte, as in you cannot hash more transaction data than that. The difficulty target of mining is kind of averaged at about 10 minutes per block, so it takes about 10 minutes, more or less, on average, for miners to find a block to add to the blockchain. The network is growing, and it's growing massively. If you look at any kind of graphs online, it's quite incredible to see, since 2009, when, Bitcoin started, how quickly it's expanded, and how much money is flowing through the network. What this means is that blocks are filling up. So because there's so many transactions that are taking place, you have transactions that are starting to be bumped to blocks down the line. So, because there's a hard limit on the size of the block, there's a limit to how many transactions can be hashed on that block. There's lots of debates about whether or not blocks are in fact filling up, or whether you have miners who are kind of mining like empty blocks, or if there's other issues, in the network. You can read about that lots, but this has created a big debate within the Bitcoin community about whether or not to increase the data size, the limit on the data in the blocks, or to find other solutions to that problem. The interesting thing, so this is a very technical question, this is a very technical decision. The interesting thing about it, though, is that it really became hugely politicized because this technical decision was potentially going to affect the decentralized nature of the network. It could have kind of longer-term effects on, it basically determined two different visions of what decentralization really means. So what we've got in Bitcoin, you've got miners who validate transactions, but you also have what's called full nodes that ensure that the kind of protocol is complied with in transactions, and they usually store the entire blockchain. The blockchain is getting bigger and bigger as the data size grows. And so this question of whether to increase the blocks or not was also a question of whether you're going to increase the kind of computational load for full nodes and for miners, making it harder and harder for kind of regular users to be a full node or to be a miner. Why is this interesting? It's interesting because it determines whether Bitcoin is decentralized at a protocol layer or not. The other version was we need to increase the block size, possibly like massively, and it's fine. We're going to have like some mining factories, and this is going to become a much more specialized game. It's going to be much more kind of formalized in that way, because we need to compete with Visa, MasterCard, PayPal, and do rapid transactions, you know, and really kind of push an idea of decentralization that's more like in terms of kind of customer. Yeah, like it's decentralized because lots of people are using it. So it was kind of two different ideas of where decentralization should be. You know, should it be at a protocol layer? Should it be as kind of users? And that also touches on power in the network fundamentally, because if the people who are validating the protocol and the people who are validating transactions become more and more centralized, you know, it's just another form of authority, right? We got rid of the banks, but we've just reinvented a different type of bank, fundamentally. So this is like a kind of conflict that I've been following a little bit in my research, also because I'm really trying to work out what exactly changes with the introduction of this type of technology when it comes to governance and when it comes to accountability and so on. So I'm trying, right now I'm in the process of trying to kind of basically map out power in the kind of Bitcoin, in the Bitcoin scene, and try and kind of take seriously the fact that, you know, one thing is to look at the protocol and how it operates, but another thing is to understand that, you know, the protocol doesn't exist in a vacuum in itself. You've got, you know, people who contribute to the core code, you know, which is a small group of people that have commit access. Then you have a larger group of people who are also, you know, contributing to the code, but they don't have commit access. Then you've got the miners, you've got the full nodes, you've got the exchanges, you've got, you know, so you've got a lot of different actors that have a different kind of role in the network. And when it comes to like making a technical decision like this, you know, that really tested the governance process fundamentally of Bitcoin. It, you know, ended up, you know, one of the kind of core developers had his commit access revoked, you know, which is and is not a big deal, but it was, you know, it was interesting to see that this technical question actually brought up some serious issues around, like, you know, okay, we haven't got rid of the problem of governance, we haven't got rid of the problem of decision making, because at the end of the day, you know, Bitcoin is code that's written by human beings, and, you know, even though like we have a computational way of coming to consensus around a set of transactions, there is still a kind of lack of, let's say, a clear structure of how decision-making around code should operate when it comes to power. There are innovations in this area in Bitcoin. I mean, it is super interesting the way that it's structured, because you do have, you know, okay, you could start by saying, right, core developers with commit access, those are the people with the power. But in fact, you know, you might commit some code, but in order for that to be implemented in the network, miners and full nodes have to adopt it. So this became a kind of, you know, big deal. There was a lot of discussion around whether to hard fork you know, there was in fact a group of developers that tried to hard fork Bitcoin, and they didn't really succeed. And they were pushing for an increase in the block size. Yeah, there was basically kind of disagreement on that, and they got a lot of flack for that. So there's a lot of processes that are being invented right now around kind of how you basically test the level of consensus amongst you know, miners, full nodes, and so on before you go ahead with a hard fork. Under what conditions is a hard fork acceptable? When should we kind of stick within a kind of like soft fork kind of scenario? What does that mean? How are debates, how are decisions, you know, taking place in this area? So, you know, I'm still mapping this field, and I'm still kind of trying to bring together, you know, the different forums where these things are taking place, because you've got like a mixture of, you know, the GitHub repository and record, you've got, you know, core developers mailing lists, you've got Reddit discussions, you've got conferences, you've got, you know, and all these different mediums and all these different spaces play into the decision-making process around Bitcoin. So there is something new here in terms of governance and in terms of power, but what exactly it is and whether we can understand it as a form of, distributed institution or what people in the crypto scene like to call decentralized autonomous organization, or something like that. It's something new that's emerging. But so kind of one of the taglines that I keep repeating is that decentralized computation doesn't equal decentralized power. We still need to map out how power is reconfigured in these types of networks. And there is a core text that has been circulated a lot in the cryptocurrency scene is Joe Freeman's Tyranny of Structurelessness. And it's quite interesting to see that that's like really kind of, people are repeating that, people are sending it around because they're starting to realize that, okay, there are people in this scene that have a kind of informal power because they've been around a long time, because they've contributed a lot to the code, because people trust them, but it's not formalized and it's not clear. So that's one thing. Same, computational consensus does not equal social consensus. This is, just something that I'm thinking through in terms of consensus protocols. And again, through this kind of like comparison between proof of work and something like proof of cooperation. Proof of work is not about social consensus. It's an algorithmic process, and it's simply a way to, by lottery, choose what pieces of data is considered valid or not. It's not like a kind of social process around like, this is more valuable or we trust these people more or anything. It's by lottery, it's an algorithmic process, which has its benefits. But yeah, so it's interesting to think through also because there is a lot of conflation in the cryptocurrency scene using words like decentralization, using words like consensus, where, speaking about it as a computational process is a very different thing from how we experience it in social life. And that's also something that needs to be kind of mapped out. And I think like even just a basic kind of, going through the Bitcoin glossary and analyzing these things, picking them out as it kind of like hovers between social sciences, computational sciences, and so on is like an interesting exercise in itself. Because a lot of these words operate both as ideology and as technology in these scenes. It's a real, like that's how the technology is designed, but it's also a certain kind of political ideology that doesn't necessarily always match up or doesn't necessarily always create the same outcomes, right? So, like going back to the Bitcoin scaling conflict, it's really this question around what we understand by decentralization and what aspects of decentralization are important to us. If it's a decentralization of social power, there might be some areas where you might want to centralize some aspects of the infrastructure in order to ensure a certain level of accountability or a certain level of transparency, going back to Joe Freeman's text around tyranny of structurelessness. It's not something I'm kind of saying should happen or I have a clear idea what that structure would look like, but I'm just saying that, these concepts like decentralization, they kind of flick back and forth between being a kind of technological specification and a kind of value that people can kind of pull out of the hat whenever they need to. But it's not actually clarified very well what type of decentralization we're talking about and how we relate that to things like power. And I don't think I have to kind of discuss that much here, but just this thing that technology is not neutral, markets are not neutral, money is not neutral, and in fact, one of the interesting things one of the interesting things with Bitcoin for me is exactly the fact that it showed historically that these things are not neutral. All of a sudden it was like a currency that was like, okay, the banking system as we know it, money as we know it, we can reinvent these things. We can encode new values into these things. And I think it's important to keep that in mind because as Bitcoin grows, a lot of people tend to forget that, A lot of people start thinking about, this piece of technology or this currency as a kind of neutral base layer without really considering that actually you can redesign the consensus protocol if you want. You can create other types of cryptocurrencies that operate on a different set of values. And that is the contribution of Bitcoin for me, really, is that it's, there's a hacker called Jaramil who wrote a paper in 2011 on Bitcoin called, I think it was called Breaking the Taboo of Money, and that's what it is for me, it's broken the taboo of money. And I think that's important to keep in mind and not just kind of see it as another neutral thing. This is something that someone just posted on my Facebook today, so I thought I'd put it up there because it's, going back to the hype of blockchain. People now want to use blockchain for everything, without kind of necessarily understanding what it can do differently from existing databases. I both agree and I disagree with this diagram because, especially when it comes to the issue of trust, I think you can do very interesting combinations of trustless and trust-based systems. And I was discussing this a little bit, I think, with Democracy Earth on the question of identity, for example, where, you might want to have, what's interesting with the Bitcoin blockchain and the kind of direction that some people are developing it in. I didn't actually finish the story fully of the scaling conflict, sorry. So one option was to, and this relates back to this, one option was to increase the block size, but you've got lots of other solutions that are being looked at now. Kind of generally, you can think of them as side chains, for example, where you might have a kind of network of people who trust each other more, or a network of kind of types of transactions that don't require heavy security, meaning like they're very small, it's like, coffee or whatever. You can have a network of transactions taking place alongside Bitcoin that then gets hashed at the end of the day, all of it together onto a block. So that means you reduce the kind of load of the Bitcoin blockchain quite significantly because you're kind of taking, what hashing does essentially is it takes a whole load of data and it compresses into a tiny string of numbers. So this is like one way of using the Bitcoin blockchain as people have described it as a kind of Merkle root of trust. So if you imagine a kind of big tree trunk of trust that the whole world can refer to and the whole world can use to anchor their data, whether it's transactions, identity, land registries, whatever, anchor it in that network exactly because it is extremely secure and it's very large at this point. You've got a lot of hashing power. But you can run trust-based systems alongside. So that for me is actually quite important, especially if we're thinking about decentralization less as let's create the decentralized system of the world that everybody must use, and instead think about decentralization as a kind of ecosystem of lots of different systems that might have their own values, their own types of currencies and so on. So, for me, the interesting model is exactly the fact that you have a combination of social currencies, cryptocurrencies, local currencies, regional currencies, and whatever, that can operate alongside each other, that can interface with each other in different ways, or various types of data and so on that you can then anchor in the blockchain. So I don't fully agree with the fact that you only need the blockchain for completely trustless situations. I think a kind of hybrid models are super interesting to play around with. Anyway, I thought I'd just put that up there. So yeah, these are kind of some of the things that we've discussed, some of the kind of characteristics of blockchain, Bitcoin blockchain. I think that's kind of what I've That was like a big. Well, has that been helpful for people? Do you feel like you understand blockchain now a little bit? Yeah? Not Ethereum, right, okay. All right, so Ethereum. Okay, Ethereum is interesting. It is a way to use the blockchain not just for transactions, but as a kind of generalized global computer. The way that it does this is it has two different types of accounts. So you don't just have accounts that people use in order to transact with their bitcoins. You've got what's called contract accounts and something else accounts. One of the types of accounts is similar to any other cryptocurrency. It's for transacting with cryptocurrencies. The other types of accounts are contract accounts. Contract accounts are basically a kind of program. You can create a kind of program that can run automatically on the Ethereum virtual machine, so on the kind of Ethereum network. And it's basically a way to execute computational functions on a kind of decentralized computer. And in order to do that, you have to pay in the kind of system's cryptocurrency called Ether for those computational functions. So there is a reason for that. Ethereum, the ambition of Ethereum was to create a generalized global decentralized computer that was Turing complete. And Turing complete means it can run any type of computational function, including loops. So they had a problem because if it was going to be able to run loops, how do you make sure that you don't get attacked by someone who just wants to kind of do an infinite number of loops, sucking up all the kind of power and attention and work and whatever of the entire network, and kind of sabotaging it that way. So they added a cost to every computational function. So you've got a cryptocurrency here that functions as a cryptocurrency, but it also functions as what they call fuel or gas in order to run computational functions on their blockchain. Again, conceptually, this is super interesting because it's like taking, in Bitcoin, if you imagine the way that, well, how I just described this combination of financial incentives and cryptographic hashing as being like the security of the network. In Ethereum, they go even further than that. They go in even deeper with that. It's, you use the kind of crypto fuel to run the actual computational functions on the network itself. They have a language that I think was called contract-oriented programming or something like that, which is kind of interesting too. So the whole way they've kind of set up this system is very much through this kind of contract based language, and that in itself is a kind of interesting thing to unpack politically and philosophically too. But yeah, so another funny story and another way to kind of like get a little bit at the core of some of the assumptions of the cryptocurrency scene, and especially Ethereum, is if you imagine that you can create these contract accounts. So contract accounts basically is a set of, you can think of them as a set of rules. It's a kind of program. In Ethereum, the idea that code is law is taken very seriously. So you write a bit of code for something to run, a program to run, and they understand that as a contract, as a legal contract. So for them, this idea means that you can combine these contract accounts to form what's called a decentralized autonomous organization that can run according to a set of rules that humans cannot tamper with. So it's on the Ethereum blockchain, it's gonna run the way you coded it, and there's nothing you can do about it. And that's the intention. The intention is that way we can get rid of human corruption, we can get rid of kind of legal loopholes, we can solve a whole load of problems that has to do with human fallibility by creating these types of decentralized autonomous organizations. So last summer, there was a group of people in a company called Slockit that developed a DAO, Decentralized Autonomous Organization, with the intention to, basically the idea was to create an organization that would distribute startup funds for new Ethereum-based applications. So it was both a kind of proof of concept around the DAO, and it would serve the community in order to fund new applications. It got a lot of attention. It got a lot of funding, and all of a sudden the DAO had, you know, $160 million worth of Ether in its account. This was way above what they expected. And then all of a sudden they saw that the account was being emptied by something like 256 Ether or something like that per, I don't know, minute or whatever. They saw the amount started to trickle down, you know. Somehow this account was being emptied. Basically someone had found a flaw in the design of the decentralized autonomous organization that allowed for this to happen. The way that DAOs were specified in their white paper was that if someone who's invested in a DAO disagrees with a set of decisions, they can fork. They can leave the DAO, and their investment, their original investment, will follow them into a new DAO. So what this person had found was a way to combine this forking with the loop function, meaning it would continuously fork off the same amount of money. So the account was slowly being emptied. You had a total crisis in the network, and you know, this was also like, you know, it was $160 million worth of Ether, which accounted for, I don't know, a huge percentage of the total kind of market of the cryptocurrency Ether in general. So it was an issue not only of the people who created the DAO, but for Ethereum as a whole and the Ethereum project as a whole. So they had a problem to solve, and they decided to implement a hard fork in order to essentially reverse that exploit or that hack, and you know, reverse the exploit so that it never happened, and then fix the problem. This is like a huge like no-no according to even like their own kind of standards or their own kind of principles. You know, because the blockchain is supposed to be immutable, meaning you're not supposed to be able to go back and say, no, we didn't mean that, right? No one's supposed to be able to do that. Yeah, so it sparked off a whole load of debates around authority, around, yeah, and the other thing obviously is that the DAO was presented as something that was going to prove exactly the fact that when you have a cluster of smart contracts like that, you have no human intermediation. The smart contracts themselves is the law. So there was obviously no recourse to any kind of legislation or any type of kind of external legal framework. You know, they wanted to avoid the courts, absolutely. And also they were faced with this problem that, like, in normal kind of law, intent plays a role, meaning like when you go to court, the actual intent of the person or the intent of the kind of contract has some weight. They were trying to get rid of that kind of gray zone, right? Because here they wanted a kind of, the whole feature was to be a kind of binary, black and white, you know, this is the law, this is, you know, the code is the law, there is no external document that can override that. And all of a sudden, you know, they're kind of backtracking massively on that, and they're saying they're going to do a hard fork. So they were criticized quite heavily in the community, but obviously a lot of the investors were quite happy that they were going to do that. And it, you know, to some extent, they had their backs up against the wall to kind of, it was a tricky one because they had to kind of really weigh up let's say, trust in the claims that were made or the trust in the kind of use of the currency and the security of smart contracts. So the hard fork happened and was accepted by the miners. But and everyone was like super happy, you know, the following day, there was a statement issued and a group of people said, you know, you can't do this, you're basically going against all the main principles of, you know, what you've stated and of the blockchain as we understand it. And they carried on mining on the old chain. So all of a sudden you had kind of two different realities, you know, two different versions of the truth. One in which the hack had happened and another in which it didn't. So, you know, another very interesting case. It brought up a lot of good discussions because, you know, there's many different ways of thinking about forks. And for some people in Ethereum, forking essentially is a way, you know, in the cryptocurrency scene, a lot of people see forking and hard forks especially as something hugely negative because it splits the network and the network is in fact more secure when it's large. So you kind of want to avoid forks. On the other hand, for some other people in Ethereum, it was interesting to have discussions around forks as a way for like the community to actually engage with the governance of the protocol. So, you know, when you have a hard fork, it's also a little bit like a polling or a voting situation. You kind of can see who's on board with those decisions or not, and you kind of force people to take sides on, you know, whether they agree with a decision or not. So, it's something that kind of politically and socially is very interesting to think through and analyze also. Yeah. That's Ethereum and DAOs and a little bit more to think about. The DAO the people who made the original DAO, they're now attempting another one. Yeah, I mean, it's good. They're brave and they're trying again. And I think this one is kind of more focused on NGOs and charity. So, yeah.
No, okay. Both networks are really interesting to do different things. For example, we look at Ethereum to make organization incorporation. It's way more interesting to do that on Ethereum because you can make it much more complex and put much more information, while on Bitcoin the only thing you can really do is like just store hashes and make something really secure, and then you have to do a bunch of things outside that relates to that hash. So I think both systems are really interesting, and what makes like Ethereum development, Bitcoin development interesting today is because like some well organized and funded projects are actually working to make interacting with those chains really easy. Like we use 21 computer to have terminal access to Bitcoin. Some guys like make some browser proxies to have direct access to Ethereum and stuff like that. So the ecosystem is growing, while before, like 1 or 2 or 3 years ago, it was like people were trying to make like a full Ethereum application. It was buggy and it didn't work and it was not that secure. And like once the network started growing, like things started to get really slow, and so now it's getting a lot more interesting because you can do much more things than before and less complex.
Yeah, no, you're absolutely right. It's like, I mean, the cryptocurrency scene in general is very varied, and people, you know, talk to each other a lot and do a lot of interesting things. And I think it's, I mean, that's one of the, for me, when Ethereum came out, there was a lot of discourse around it. They presented themselves as kind of the next generation, and that Bitcoin was going to become obsolete. And I think that's changed. The vibe has changed a little bit now. Ethereum no longer is kind of going to be the only platform out there. I think everyone understands that there's going to be lots of different platforms and lots of different currencies that can do very different things. Yeah.
It's for the video, right? I guess.
Yeah, I think they're recording the session, so.
Works, yes. Thank you, because I got to understand a little of the behind the scenes part, and that's pretty cool. Thank you. Two questions. First is, you were working on that rich map analysis. So what does it look like right now? And second is, it's more or less a question, but let's see if I learned the lesson well or not. Meaning that if we wanted millions of people to go on board tomorrow on Bitcoin, they couldn't. The system couldn't handle it.
Okay, yeah, so question number one, the mapping is where I'm at right now. I've kind of, so far I've just created kind of descriptions of different types of agents in the Bitcoin kind of scene. So I've tried to map out exactly who can take what types of decisions, who can implement those decisions and that kind of thing. So it's like a description of. I've tried to create a more full description of the governance model of Bitcoin, because that doesn't really exist anywhere. It's really hard to find online how Bitcoin operates outside of the protocol. Like, there's lots of glossaries and very good descriptions around how the protocol operates, but everything around it, let's say the human aspect, is not so well mapped out. So it's still very much in the beginning, and I haven't published anything on it yet, but I'm hoping in the next month or so I'll have like a good map and a good description of the different types of actors. Basically what I'm trying to do with that is to try and compare it a little bit with existing institutions. Because what's also interesting talking about Bitcoin and scale is that it's clear that there's like a different set of questions that have come into play now in Bitcoin than there was before, because when you start off as a kind of bunch of people who all have some kind of experience in computing, and everyone's kind of mining their own Bitcoin, and everyone's kind of trading, you can see that as a kind of peer-to-peer network, and you can see that as relatively horizontal, But when you're creating a currency that all of a sudden is at a scale and is facilitating transactions and money flows for a lot of different types of people, a lot of different types of businesses, like the question of accountability comes in a very different kind of way. So it's also that like Bitcoin, it's not just like that the scaling issue is one of block size, it's also a scaling issue of we're facing a different set of questions around accountability, and we're facing a different set of questions around decision making on whose behalf and who's represented, in those forums. So yeah, I'm kind of trying to, I guess, claim a little bit or push a little bit and challenge a little bit the idea that we've got rid of the need for institutions and systems of accountability, and to say that actually that needs to be kind of like redesigned and rethought through for the Bitcoin case in some way, and maybe actually try and take it seriously as some form of decentralized institution. When it comes to whether Bitcoin would work if all of a sudden millions of people start to use it, yeah, there would probably be some problems. You're right. It's like, yeah, there will be some problems. I mean, it's growing very quickly as it is, but yeah.
So one of the things that worries me about cryptocurrencies is their cryptoness, not in the algorithmic part, but in their opacity, in the sense that they are intended to provide a trustable fabric for exchange or something like that. But to me, everything I know about them and read about them, they show up as somewhat inhumane, in that they don't think about the sort of psychological or social or emotional needs of the people dealing with them. There is no identity concept, just a string of numbers. There is no, I think it's really interesting, this discussion around governance of the currencies relative to the code base, relative to the algorithms of consensus, for example. So I'm a little scared, I guess, that they're, if it is the operating system for future transactions, that it is being designed by people who don't actually understand people. So any, like, reactions?
Yeah, lots of reactions. I mean, it's part of this thing that I'm thinking through around, you know, technology and neutrality and this kind of stuff, right? That you know, there is a kind of underlying mistrust of human beings in the design of these systems. And, well, I wouldn't even say underlying, I would say very explicit. And so one way to think about technology neutrality, I think a lot about the two concepts. Delegation is a way for me to think about how technology is not neutral. So what I mean by that is that you delegate certain functions to a technology. Decisions that are ethical, that are political, and so on, that you then encode into a technology that then runs automatically. But more than delegation, I think translation is a more appropriate concept for that, because you're actually translating, like, qualitatively those decisions as you're encoding them into the technology. And there is a strong ideological element to that that has to do with believing more in maths than your fellow human beings, and trusting more in maths than your fellow human beings. And it's, you can see why that's attractive, and you can see why that's kind of, for a lot of people, it quickly resolves a lot of problems, because you no longer need to deal with the complexity that is the real world. Are you like keen to answer back to that?
Yes, but it's like, I trust math when it comes to computation, but not when it comes to morality, right? I mean, this is the disconnect that I suffer.
Yeah, yeah. No, absolutely. But here they're going further with that. And it's, it relates in an interesting way also to scale, and it relates in an interesting way to markets. I mean, what's funny in kind of Bitcoin and also Ethereum is how the idea of markets as an information system rather than kind of just a kind of market system is taken very seriously, and they've pushed that even further. It's a very kind of Austrian school Hayek kind of understanding of reality and how we relate to each other. And it's being implemented as an infrastructure in order to, I mean, the question of scale comes in here because it's like a very strong imaginary of how you deal with large-scale situations where you don't trust other people. So you create this kind of base layer that, you know, mentally has become super neutralized. I mean, people understand the market, understand technology in this very kind of neutral way. It's like money, technology, you know, is neutral. It depends on how you use it, right? Not kind of looking at the fact that actually it's fundamentally political. In fact, it's like the most political things that we've got, you know. Now, I mean, the way you design the technology or the way you design the money has massive effects. But yeah, this kind of humanizing aspect, or dehumanizing aspect of the technology, I mean, I completely agree with that there needs to be a kind of some thinking around how to rehumanize those engagements. But I do also think that I'm hesitant to kind of have a kind of reaction against it that's immediately negative, because I think that there is, like I was talking about before, this combination, these hybrids of kind of trust-based and trustless systems can be really useful, exactly because of the question of scale and because of the question of distance. You can create something really effective there, of encouraging, very tight networks of trust. What Faircoin is trying to do is they're trying to do exactly that. They're trying to create a kind of situation where you have like locally, very kind of trust-heavy situations that can then use a cryptocurrency in a decentralized ledger to interface with a kind of global system. So it's a way of kind of leapfrogging, let's say, governance institutions at other levels. So, you don't have to pass through the nation state to go from the local assembly to a global scale where you're connected up with other local assemblies, And there's interesting possibilities there. But it is very different philosophies, because Bitcoin is going straight for trustlessness because it's easier in a way. You have a protocol that's automatically enforcing rules of engagement, which means that you no longer have to make some difficult decisions around that. Faircoin, it's going to grow quite slowly, probably. It's going to be quite tedious, probably, because it requires a lot of time in assemblies, and because it requires that people actually meet each other, and that they actually trust each other, and that they're actually on board in some kind of shared vision of a common kind of movement that is like based on certain kind of anarchist ideals and certain ideas around ethics and so on, and cooperative structures. So, the two things, yeah, they're very different. But they do, there is some, Faircoin, they have been looking at Bitcoin. There is like a lot of kind of conversation back and forth too.
So I just want to say thank you. That was beautiful. I was riveted. I am a mathematician. I love the dehumanizing formal system part of it, even the Hayekian part. That's my ideology. So I love it. I love how you reserve judgment. I love how deep you go and how fluently you explain it. I mean, I ate it up. It was beautiful. Thank you. And so yeah, the point I wanted you to go more in depth, which is the one I'm less familiar with, is Faircoin. I'm interested about that. What's a turn? How long does a turn last? What kind of decisions are you supposed to take with Faircoin? Could you go into that a little bit more? And thanks again.
Sure. I can't remember right now how frequently they mine blocks. Actually, I'd have to look that up in their white paper. I can't remember. Sorry. Yeah, in Bitcoin. Faircoin. No, they don't need to meet. So, sorry, that's a kind of misunderstanding. So, no, it is still a computational process. And it happens relatively automatically, as in, the program checks who mined the previous block, and then it'll kind of pass the turn on, and there is like various aspects to it that is automated. What I mean about the face-to-face interaction is that I think the way they've set it up now, because it's actually just in the new implementation of Faircoin that they've implemented the certified node validators. It's still quite a new thing for them, and I think it's something like, you need to take part in some of the assemblies which take place on Telegram, and then they send you like a card that has a chip or something like that then means that you become a kind of that combined with the client then means that you're a certified node validator. I can't remember the entire process, but I'm going to be testing one and setting one up in London to check it out and see how it works. But yeah, the structure fundamentally, you've got, so the heavy kind of face-to-face aspect of it, so in Bitcoin you have miners, you've got full nodes, you've got the core developers, you've got lots of different actors. In Faircoin, the kind of main actors are, you've got local nodes, you've got the global assembly, and then you've got the certified node validators. Certified node validators can be like, a couple people in a computer. It does, it's not like super kind of, but they need to be trusted, so take part in some of the global assemblies and, be in contact with some of the core developers. And there's like a kind of questionnaire also around like your position in terms of like different kind of ethical questions and stuff like that, and you need to kind of comply with some basic principles of cooperative structures. The local nodes are the kind of interface with local producers, so they interface with kind of co-ops in the local area who want to start using Faircoin. And they operate as like exchange offices and as kind of support on that front. And they need to be minimum 3 people, and they have to operate as an open assembly that takes consensus-based decision-making processes. Yeah. What one?
Like metadata about the cellular phone business, you can know who is contacting who. And if you have this data, you can probably, if you are a good researcher with good tools, know who has transactions with who. So the archive thing can be also a problem in that sense that it's not really anonymous. And the fact that we are in a society that archives grow and grow, which can be dangerous. So what are your thoughts about that?
Yeah, so there's some interesting papers and some interesting research done in the computer engineering department at UCL in London. A woman called Sarah Michael John and her team wrote a paper exactly about how to trace transaction, or how to trace, basically they were testing whether money laundering was possible using Bitcoin. And they ran a bunch of tests on that. And the main kind of weak point for them was, that they saw was that at some point there is an interface with some form of exchange to fiat currencies. So even if you kind of, basically they said exactly what you're saying, that there's issues around anonymity, especially for transacting like large amounts of Bitcoin. You know, and then for the casual user, there's the issue of metadata, because, you know, unless you have some extreme kind of security practice in place, you know, you are going to be able to be traced in all the usual ways that probably a lot of us are familiar with on our phones or whatever else, whatever other type of device you're using. So it is an issue, and you're right, like historically it's going to become a problem. Archives can be really dangerous for that kind of thing. Yeah, it's a problem. There is work being done in this area, though. People are taking it seriously. And there's one of the proposals in the Bitcoin scaling conflict that I still need to get my head around, called segregated witness, that is looking at another problem around anonymity. There's a concept called fungibility, which means to what extent a currency is, to what extent, like, say, a €5 note is the same as any other €5 note, or if there's ways of actually marking that note. And in Bitcoin, there is this potential problem that the cryptocurrency can be used to kind of mark when it's passed through a black market or something like that, that you can actually kind of start creating these like tags or stamps or some kind of way of tracing Bitcoins as they've kind of passed through illicit uses. And that's another kind of issue around anonymity, and another issue around the archive and the problems of the archive. But so if you want to like really do some deep research into it, you can look into the segregated witness stuff that people are developing at the moment. But yeah, that's just to say that it is a problem, and it's something that people are researching and trying to develop solutions for. Any other comments? Was that like useful for people? Do people feel like they more or less have a better grasp of what the blockchain is and the political questions around it? And yeah, more or less. Okay, great. Good. Thanks very much for coming.
Lo iba a anunciar. El nieto de Emilio Aragón, no, de